Hello everyone, how are you? I hope you are good. So, if you are learning pandas just to run head method and group by method, I'm so sorry. But that's not going to get you higher. In real company, pandas is not about the syntax. It's about solving messy business problem, dirty data, broken Excel sheet, and dashboard that CEOs actually use. So in this course, I'm not going to teach you pandas like a textbook. I'm teaching you how it's used by real data analysts in production. I'm teaching you how it used by real data analyst in production. You can see here on the screen who this course is for. This course is for beginner who want to become job ready, who want to do some project, who want to do some analysis project, data analysis project, okay? And this course is for data analyst. I mean analyst who know the basic but struggle with the real data sets. Okay, and this course is for anyone who is preparing for data analysis, data science, and AI ML interviews also. Okay, we also create project in the end of this course. Okay, so you can see here we have syllabus of this. Okay, so in phase 1 we start with how pandas actually work internally. Okay, here in the phase 1 we start with how pandas actually work internally, not just syntax but performance and memory. Okay, and in phase 2 you can see here core data structure. Here you can see, then we master series and data frames, the two type things you will see use 95% of the time. Okay, and phase 3 we are going to cover real data cleaning. Okay, then we are going to cover, I mean, becomes the part most tutorial ignore. Okay, messy data, missing value, duplicates value, wrong formats, and real world problem. Okay, and for this analysis skills I'm going to cover for analysis skill in phase 4. Okay, so after that we move into group by. After third phase we move here in phase 4, that is analysis skills. Okay, so we move into the group by aggression and business metrics. This is where analysis actually happen. Okay, and fifth one is, after 4 we have this fifth one. Okay, advanced skills. So here we are going to cover joins, time series, performance optimization, the stuff used in real companies. Okay, so we are going to cover these 6 phase. Okay, foundation first, and core data structure in second phase, real data cleaning in third phase, and data analysis skills in fourth phase, and advanced skill in fifth phase, and phase 6 real project. And I also mention in the last of this course interview questions of pandas. Okay, so this is our syllabus that I'm going to cover in this course. By the end of this course you won't just know pandas, you will be able to clean data and analyze and build a real data workflow like a professional data analyst. Okay, so let's start with the most important part, setting file, I mean setting our environment and create the file, and understanding how pandas actually work under the hook. Okay, so we are going to start now. Now you have a question in your mind that what is pandas. So before we start coding, let's understand what Pandas actually is. Pandas is a Python library used for working with data, especially structured data like tables, Excel, files, and CSV. Think of it like Excel, but more powerful and automated. Okay, in Pandas, Data is stored mainly in two data structure, two type of data structure, that is series and pandas. Okay, series means, series is like a single column. Okay, and data frame is like a full excel sheet. Okay, we have, many rows and many columns. Okay, so almost everywhere we do in data analysis happen inside the data frames. Okay, now in your mind maybe you have second question, that is why are we learning this. Okay, so pandas is used in, no, pandas is the tool we use to. Okay, pandas is the tool we use to clean the data, transfer the data, analyze the data, and preparing it for dashboard or machine learning. Okay, so in real companies data doesn't come clean. Okay, it comes messy, and it has missing values, it has wrong format, and it may be contain duplicate value. So we need to clean our data by using data cleaning. We need to transform our data by using data transformation. We need to analyze the data. Okay, and prepare it for dashboard or machine learning. Okay, now third question maybe in your mind, where is pandas used? Okay, so pandas used in where? Data analysis. First point is data analysis, second is data science, and third one is business intelligence. Okay, so we use data analysis here, also in finance and marketing analysis, also finance and marketing analysis. So basically anywhere data exists, pandas is used. Okay, and you can see here real life example. Okay, so in pandas you can find out total revenues, filter the top customers, and calculate the growth. Suppose we have one example. Okay, suppose we have one example. Let's say you have 1 lakh row of sales data in excel sheet. Okay, in excel sheet we have 1 lakh row of sales data. It becomes slow and painful. Okay, so in pandas you can find out total revenue, filter top customers, and calculate the growth. So we can find out all in a few lines of code. Okay, so that's why we use pandas. And by the end of this course you will be able to handle real world data set, perform analysis like a data analysis. Okay, data analysis you can after this you will perform like a data analyst and solve interview level problem with confidence. So here I'm going to create one folder. Okay, its name is pandas mastery course. Okay, so I'm going to open VS Code. You can create here this folder anywhere, like in D drive, C drive. Okay, or in desktop. I'm just going to create here because I have problem inside my D drive. I'm unable to create virtual environment there, so that's why I'm using here. Okay, so where is our folder? This one. Okay, so here I'm going to create folders. So these are first one. I'm going to create folder that is setup. Inside this I have one folder setup, and inside this I have one file. I'm going to copy this and paste it here. Okay, so we need to create these folder and file. Inside this folder I'm going to create this file. Okay, again I'm going to create this folder. Here I'm going to write series. Okay, again I'm going to create data frame 03 data frame. Okay, so this is our another folder 03 data frame. Again I'm going to create folder name, that is 04 data cleaning, 05 group by. Okay, and 06 merge and join. Here we can write the code for merge and join. Okay, so these are the folder, guys. Okay, and 7 is time series, 07, that is time series. And 08 is performance. And 09 is project. Okay, guys, and I'm going to create 10 also. So how can we write this name? 10 interview problem, interview question. I'm going to remove problem from here. Interview question. Interview question. So here and 11 is practical exercise. So here I'm giving name practical exercise, G double one practical exercise. Okay, now guys, now we have completed our all folders. Inside this we need to write file name. Okay, so I'm just going to copy and create every file here. Okay, so here in series file I have this series py, and in data cleaning I have this file. File number 4 here, cleaning. What I forget to create file inside the folder 3 data frame. And fifth is group by .ipynb. Okay, so here we have group by. Okay, and sixth one is sixth file, that is merge.ipynb. 7 is for time series. Time series. And 8 is performance. Oh, I forget P from here. Okay, so here I need to create one file, performance.ipynb. And here we have in project 9 we are going to create one file, that is project.ipynb file, and we will use data sets, so that's why I need to write data sets, that is folder name. Okay, here in folder 9. Okay, this is the folder name, this is the file name. Again, I'm going to create another folder, that is data frame. Okay, if we have any data sets, then we can write, we can put here inside this data sets. If we have any data frame, like if it is in CSV file, if it is in Excel, like we have data in any file, so we can put this file inside this data sets folder. Okay, again I'm going to create another file name, that is interview questions. Inside this interview question dot IPYNB. Here array, and here we have practical exercise IPYNB. Okay guys, now you can write your code here like this. And one file is readmd. Maybe I have readmd file. So I need to close these files. Okay, I will create later this file readmd. Okay, readme.md. So here this command I'm going to run for create the virtual environment. Okay, so you can see I got my virtual environment here, venv. Okay, so here we can store, we can install everything. Okay, now I am going to activate this virtual environment. I hope you already know how to create virtual environment, okay, and how to activate virtual environment. So with the help of this command venv hyphen script activate, so we can activate our virtual environment like this. Okay, now I need to create one more file. Okay, that is requirement.txt. Here I'm going to install, here what I want to install, I need to put. Okay, so here I want to install pandas, I need to keep pandas here in requirement.txt, and here I am going to run this file. Okay, how to run this file? Pip install hyphen let me check, hyphen r. Okay, requirement.txt. Maybe I have this command in my terminal. If not, then I will this one, pip install hyphen r requirement.txt. Okay, so it is going to install the pandas. Okay, so you can see I have installed pandas. Now I'm going to start writing a code here. Okay, so this is our Jupyter, IPYNV file. Okay, in Visual Studio. So here I have this, and this is, here we can write the code, and if you have text you can write here. Okay, so first thing I'm going to write here That is what here actually I have some text inside this. Okay, I'm going to copy this and paste it here in Markdown. Okay, so this is the detail of this course. Okay, Pandas Mastery. Okay, ready. Pandas Mastery Industry Ready course for data analysts. Okay, senior data analysis edition complete production guide. Okay, so who this is for: data analyst, data science, business intelligence engineer level. If you are beginner, if you already know Pandas, then you can also watch this. Okay, so it is like from beginner to advanced level. Okay, goal: Pandas proficiency used daily in real life companies. Okay, Pandas proficiency used daily in real companies. Okay, or this is our course outline setup. So I'm doing this thing: setup and Pandas internal. Okay, and second is series, third is data frame, fourth is data cleaning, fifth is group by, sixth is merge and join, seven times series, eight large data set and performance project in nine. Okay, and 10 is interview problem, and 11 is case study and practical exercise. Okay, so here I need to mention one line. This is a module 1 setup. Okay, so this is also in Markdown. Module 1 setup and Pandas internals. So I want, if you don't want to install by using requirement.txt, then how can you install? Okay, if you don't want to install like this, then how can you install here? So you can use like this. Okay, need to click here in code. Okay, select kernel, Python environment. I already have environment, that is venv. Okay, I'm going to use this virtual environment, and here I'm going to write this command here: pip install. Okay, pip install hyphen pandas numpy. 1 minute, I use this line. Pip install pandas numpy matplotlib c1 open PyXL and XLRD. 1 minute. Oh, here you can see it is saying change the kernel, or we can say install. So I'm going to install this. Okay, you can see installing ipy kernel. So it is going to install pandas numpy matplotlib c1 open PyXL XLRD. Okay, so we can install these things. So if you are using Jupyter Notebook or Google Colab, you can install all the requirement like this. Okay, all the required library you can install by using this command. Okay, so here I have module 1. Now I am going to import here. Okay, I'm waiting for a complete of this. So now I'm going to import here. First thing, I'm going to import pandas. Import pandas as pd. Okay, you can see now I have finished installation. Okay, you can see now I'm going to import pandas as pd. Okay, I'm going to import numpy as np. I'm going to import numpy as a np. And now I'm going to import warning. Okay, and again I'm going to write here warning dot filter. Warning dot filter warning. Here I'm going to ignore warnings. Okay, so we import pandas here by using pandas as PD. Okay, and numpy as NP. Okay, these are standard convention used everywhere in industry. Okay, so we also ignore the warning by using this import warning and warning filter warning ignore. Okay, so we also ignore warning to keep our output clean while learning. Okay, so in production you usually handle warning properly, but for learning we keep things simple. Okay, now what I'm going to do here I'm going to print version. Okay, first I'm going to print f pandas in a string. Okay, so here I need to write pandas. I need to use columns, and here I'm going to print pd dot underscore version underscore. Okay, again I'm going to print what in place of pandas I need to print numpy hyphen in place of pandas I need to write np dot underscore version. Okay, okay, so with the help of this we can find out the version of pandas and numpy. Okay, so this print the version of pandas and numpys we are using. This is useful because sometimes behavior changes between versions, so in real project we always keep track of it. Okay, so here we will check, we will check the version. Okay, so I put in comment that it is version. Here we are going to check version, checking version. Okay, so you can see we have version of panda that is 3.0102 and here numpy version 2.4.4. okay, so after this I'm going to write what these are the versions, and here I'm going to write here in comment I'm going to mention display setting. Okay, display setting. So here I'm going to write code. So here I'm going to write pd dot set option. Here I'm going to set options. Okay, so first thing I'm going to display. So here I'm going to display dot maximum column underscore column, comma I'm going to use 50. Similarly I'm going to use for others. Okay, so here I'm going to write display in place of column I need to replace it with row. Okay, and it should be I'm going to take 100. Okay, display maximum in place of maximum column I'm going to write float display float underscore format. Here I need to put comma I need to write colon comma point 2 for float. Okay, this is for float, guys. Okay, and I'm going to use dot format here. Dot format. Hmm. So here I'm going to use dot format. Okay, so it will give you in float. Okay, it will display in float. Okay, and here after this I have one display dot width. In place of maximum width, sorry, maximum column, I need to write width. Display dot width, that is 1000. Okay, 1000. Okay, so you can see here, these are what, these are the global display setting. Okay, something almost every day analyst configure at the start of a project. Okay, something almost every day analysts configure at the start of the project. By default, pandas hide the columns. Okay, by default, pandas hide the column and row. By default, pandas hide the column and row when the data set is largest. Okay, so here we are telling pandas to display the, I mean, show the more column and show the more rows. And here you can see format number nicely. Okay, if we have format in, like we want like a data type in float. Okay, so it will show you format number nicely by using this line. Okay, and you can see here and use full screen width. Okay, and you will, I mean, we will say the pandas and you use full screen width for better readability. Okay, so that's why I need to write here display dot width. Okay, it means use full screen width for better readability. Okay, so this doesn't change the data, it's only changes how we see the data. Okay, so here sometime pandas may be hide our data, so we can say show me more column, show me more rows. Okay, and display nicely in format. Okay, and so with full screen width. Okay, for better readability, that I can read properly. Okay, oh, I got error, display format is not find out. 1 minute, I'm going to copy this one. I put it here in one place, guys. Okay, this is for display setting, this is for version. 1 minute, let me check why I got error here. Okay, I got error because I did a spelling mistake here. Okay, okay, show and also it should be columns and it should be s rows. Okay, so it will give you columns and rows. Okay, guys, so here this is our code finally. Okay, so it will give you maximum columns and it will give you maximum rows, I mean, so maximum columns here, and it will show you maximum rows. Okay, and it will give you nice format, and this is for displaying on full screen, so that's why we use width here. Okay, and you can see we have version that is 3.0.2 and numpy version that is 2.4.2. Okay, so these are the global displays, these are. Okay, so these are the global display settings, something almost every day analysts configure at the start of the project. Okay, so why default pandas hide the column, so that's why we need to write like this, so columns, so rows. Okay, given nice format, and also print data in a, I mean print the result in a full width on a screen. Okay, so this doesn't change the data, it's only change how or see the data. Okay, so after this, so here after this, uh, I'm going to create one markdown cell that I want to write here some text. Okay, so text like this. Okay, how pandas store data internally. Pandas data frame are backed by numpy array, or you can see here arrow array in newer version. So understanding this is a critical for writing the fast code. Okay, so you can see we have data frame, column, and block. Okay, block like we have numpy, nd arrays, and continuous in memory, continuous memories. Okay, so you can see we have this data frame. So now this is something most important thing. Okay, people sometimes skip this, I'm not going to skip this. Okay, so this is the data frame. A panda data frame is not magic. Okay, it actually built on the top of numpy. Okay, panda data frame is not magic, it is actually built on numpy arrays. Okay, it is built on top of the numpy arrays. Okay, first we need to learn pandas and then we can learn numpy. Okay, because panda data frame is not magic, it is actually built on top of the numpy numpy array. Okay, so each column in data frame is series. Okay, like if we have data frame, okay, so each column in data frame is like a series. Okay, and internally pandas store data in block of numpy array. Internally pandas store data in a block of numpy array. Okay, if multiple column have okay, if multiple column have the same data type. Okay, if we have multiple column inside the data. Okay, so if multiple column have the same data type, like all integer or all floats. Okay, so pandas store them together in a single block, which make operation faster. Okay, but if your data frame has mixed type data, if number, if somewhere is present number, if somewhere is appearing string, somewhere is object, so pandas has to create multiple block which make the operation slower. Okay, so you can see here same data type column. Okay, if we have different column, okay, and they have same data type. Okay, same data type column share a single block, so pandas give you fast operation. Okay, if we have mixed data type, like we have multiple columns, somewhere we have a string, somewhere we have float, somewhere we have integer, somewhere we have bool. Okay, so it will give you it will create the multiple blocks for different data type. Okay, and it will make your code slower. Okay, so this is why we use df.select underscore data type plus keep clean data type matters. Okay, so here I hope you got it. Okay, so now now that uh, I have finished our first module. Okay, now I have finished my first module. This is our first module, guys. Okay, I'm not going to display here result because I don't have any data frame here. I will create data in next module. Okay, and handle everything. Okay, so we are going to move in next module. Okay, now our first module is going to be finished here. Okay, I hope you got it. No, what's going on here? Now we are going to start module 2. Now that we understand how pandas work internally, let's move to the first core building block, that is called the series. A series is a series is essentially a single column of data which labels. Every column in data frame is actually a series. So if you understand this well, half of pandas become easy. Okay, think of like an Excel column but with the more power. So like we have Excel column, this is called the series. Now we are going to move in series. I already finished this part, setup.ipynb. I already finished this file also. Okay, now we are going to move here in series. Okay, so I already mentioned some comments here, okay, that you will get properly. Okay, so here we are in module 2 and topic is series. Okay, so what is a series? Series is a bundle level array. Every data frame column is a series. Okay, every data frame column is a series. I'm going to create one series, okay, from list. But before creating series, I'm going to import something. Okay, I already explained. I'm going to import pandas, numpy, and warning. Okay, that it will ignore the warnings. Okay, so in previous video I already explained these things, so I'm going to write the code directly. Okay, so I already mentioned this one here in module 1. Okay, I'm going to close module 1. Okay, and in module 2 I paste it and I'm going to run this. Okay, now I'm going to create series from list. Okay, so what I'm going to do, I'm going to create one variable here, that is revenue. Revenue equals to pd means pandas dot series. Okay, and inside this I'm going to create some data, monthly revenue. Okay, so I can create like this, monthly revenue. Okay, comma 95 comma 95,000 comma 142 0 88 0 175 0. Okay, means we have monthly revenue like this. Okay, so revenue equals to pd dot series, in bracket I have monthly revenues. I need to put comma here, and here what I'm going to do, I'm going to create index for this. So here I'm going to create index equals to, I need to mention January here, comma Feb, comma March, comma April, comma May. Okay, so these are our index. Okay, and this is our monthly revenue. So here I'm going to write, I'm giving here label, that is name equals to monthly revenue. Monthly revenue. Okay, now bracket is closed here. Okay, so revenue equals to pd dot series. Okay, so we have this, this data, we have monthly revenue, and this is our index. Okay, if I'm going to print this revenue, I'm going to print revenue. Again I'm going to print in f string, I'm going to print slash n data type, d type in another line. Okay, so here it will give you revenue with its data type. D type. D type. Here you can see I have revenue. Now I am going to print index. Revenue dot index dot to list. It is giving you revenue in list. Okay, it should be here. Okay, I'm going to run this. So you can see here, first it is giving us revenue. This is our revenue. Okay, so this is our revenue, and here you can see we have name. Okay, monthly revenue, and its type is, data type is integer. Okay, so its name is monthly revenue, and data type of this integer. Okay, integer 64, integer 64 byte, 64 byte. Okay, so you can see here we have this in integer. Okay, so revenue dot d type, so it is giving you its data type. Okay, and here I am going to print this index, revenue dot index in list. Okay, so you can see here we have list of all index, that is January, February, March, April, May in the list. Okay, and here with the help of this I got this. Okay, so guys, this is the series. Okay, so you can see here I already mentioned a series is a 1D level array. Every data frame column is a series. Okay, so this column is called the series. Okay, so here we have created series, a monthly revenues. Here this one, a series for monthly revenues values. Okay, these you can see here, these number represent the revenue for each month. Okay, and index and value, so you can see we have values, this one. Okay, so these number represent the revenue for the each month. Okay, and in index you can see here index, what is the index, this one. Okay, so instead of default numbering we are just manually assign the label like January, February, March. Okay, this is called the index. It give meaning to each value. Okay, so this is what make the pandas different from a simple Python list. Okay, data become label now. Okay, so here after this, what is the name, what is the meaning of name? So we also give the series a name. Okay, monthly revenue. The series name is monthly revenue, which is useful when working with the multiple series or data frame. Okay, and you can see we have this one revenue. So when we are going to, when we print it, pandas show actual structure output. So you can see this is our actual structure output, value on the right side and index on the left side, this one. Okay, so this already look at, you can see here this is in table. Okay, even though it's just a one dimensional structure. Okay, this already look like a small table, even though it's just like a one dimensional structure. Okay, and with this line means this tell us the data type of the value inside the series. Okay, and this line means this show all the index level as a Python list. Okay, so internally pandas keep track of these labels separately from the actual data. So that's why we can access value using name like January, March instead of just positions. Okay, so the actual in series we always have two things, actual data. Okay, actual data and the index that give meaning to the data. This one. Okay, we have actual data and index that give the meaning to the data. So think of a series as a label list, not just a value but value with the context. Okay, now we are doing something. So here you can see from dictionary to most common in real world. So here I'm going to create so another thing. Okay, so let's start, let's look at more practical way, okay, of creating a series. I'm going to use dictionary to create series. Okay, before I use list here, now I am going to use dictionary. Okay, so here we are going to create a series from a dictionary where the key become the index. Okay, we have two things in a dictionary, key and values. Key become the index and the value become the data. So this pattern is very common in real world analysis. Okay, so this pattern is very common in real world analytics working with the KPIs, key performance indicator. Okay, KPI means key performance indicator. Okay, okay, so I'm going to mention here code of line. Okay, so here I'm going to create from dictionary to most common in real work. Okay, I'm going to create series by using KPIs. What is the KPIs? Key performance indicator. Okay, so KPI equals to PD dot series. Okay, and here inside the list I have dictionary. Okay, we have two things, keys and values. Okay, so here I need to mention total revenue. So you can see here total revenue is this one, 6,20,000. Okay, guys, Python totally ignored this underscore. Underscore is just for that you can read the properly. Okay, it is for easy to readable. Okay, we are going to use underscore that we can read easily. Okay, so I'm going to write. Okay, so I have these keys and values. Left side, sorry, right side we have keys and left side we have values. Okay, sorry, these are the keys in left side, and right side we have values. Okay, total revenue that is 6,20,000. Total order 4,820. Average order value that is 128.63. Churn rate 5.2 and NPS score that is 72. Okay guys, so instead of list I'm going to use bracket, curly bracket, round bracket, whatever is it. Okay, so I can't use list here. Okay, so KPI equals to PD. Oh, uh, I put wrong order of bracket. Okay, now it is perfectly fine. I'm going to run this. I got again error. Oh, here also I put wrong bracket. Now it is fine. Okay, so you can see here I got total revenue that is 6,20,000. Total order 4,820. Average order value 128. Churn rate 5. NPS 5. Data type float. Okay guys, because we have everything in floats. Okay, because you can see here we have everything in floats. Okay, so here we are, we have created series from the dictionary because I use dictionary here. Okay, okay, so the key become the values and the value become the, sorry, the key become the index. This key become the index. This is the index, and the value you can see here, this is the value become the data. So this pattern is very common in real world analytics when working with the KPIs. KPI means key performance indicator. Okay, so here you can see total revenue. Total revenue means total money generated. Okay, and total orders means number of transaction, and average order value means average revenue per order, and churn rate means percentage of customer leaving. NPS score means what? Customer satisfaction matrix. Okay, so I mean this makes easy to create the series with the help of dictionary. Okay guys, so this is our series. Okay, now we can print here our KPIs. Okay, and you got this result. Okay, and here you can see left side we have the index. These are the index guys. Okay, okay, these are the index means KPI name. Okay, and right side we have the values. So this is why series is perfect for storing the summary in the table. Okay, while data frame are used for full data sets. So series is perfect for storing the summaries of the data, while data frame are used for store the full data set. Okay, and also notice the type of data set here you can see. So we have both like we only have here float. Okay, so pandas automatically handle the data types. Okay, like it is in what it is in float, or it is in integer. Okay, now here I'm going to write code for indexing and selection. Okay, so I'm going to I already have some line of code here for indexing and selection. I'm not going to print again manually, so here I can print. Okay, so this one. Okay, so one thing to keep in mind, since index is level based, you can say index is level based, we can directly access any KPI using its name. Okay, so we can access any KPI using their name. Okay, so like this, print revenue from the January. Okay, we want revenue from the January month. Okay, like this, so it will give you revenue of January month. Okay, you can see we have this series name is revenue. Okay, here I pass the Jan. Okay, so it is giving you revenue of January month. Okay, this will give you revenue of January month. Okay, so whenever you need to represent summary metrics or KPIs, creating a series from dictionary is the cleanest approach. Okay, and here you can see this is the label based indexing. We are accessing data using the index name. In this case we use January. Okay, so instead of position, here you can see instead of position we use the meaningful label. Okay, you can say positional integer. Okay, so here we are accessing data using the position like a normal array. Okay, and here you can see what zero, this one 0 means first element. Okay, 0 means first element, this line. 0 means first element, 1 means second element, and 2 means third element, like this. Okay, and so on. And this can sometimes be confusing because pandas support both label and position based indexing. Okay, so here you can see this line. So we are slicing labels. You can see here we are slicing labels. Okay, label slice inclusive on both end. Okay, so unlike Python, label based slicing in pandas is exclusive, meaning both start and end value are included here. This is for start and this is for end. Okay, I means we want data from January to March. Okay, I means we want revenue from January to March, so we can say it is label based indexing. Okay, and here you can see in revenue, in this table revenue, we want revenue that is greater than 1 lakh. Okay, so it is give you boolean mask. Okay, So this is boolean filtering, one of the most powerful feature in the pandas. Okay, we are keeping only those value where revenue is greater than 1000. Here we are keeping only those values where revenue is greater than 1000. Okay, and we can also use positional slicing. Okay, so now we use ilog. Here ilog, okay, which is strictly position based indexing. Here slicing behave like a normal Python. The end index is not included. Okay, so I'm going to run this. Oh, I got error. Maybe first thing. Oh, I need to run this. I need to run this. I need to run this one, and I need to run this one also. Maybe I have a small j. This is a small. I need to change here. J should be capital here. Mm, revenue of Jan 1 minute where I got. This is Jan March. Okay, so I am going to check here. This is Jan, Feb, April, March. So guys, you can see here in old pandas we use this revenue at zero index. Okay, so this is positional waste, but now pandas remove this. Okay, in place this what we have, this one. Okay, positional waste, revenue dot ilog 0 and positional waste. This is a positional waste. Okay, so I got our output. Okay, so you can see print revenue of January month. So I got this one, revenue ilog 0 positional a 1 minute. We can check one by one. Okay, so first thing I'm going to print only for January month. Okay, revenue for January month. Then I can print revenue ilog 0. Okay, at index 0 what we have, this is giving the index like this, so it is giving the first revenue. Okay, this one. And now I'm going to print second, revenue from January to March. Okay, so here from January to March, this is the revenue. You can see here 1,20,000, 95,000, 1,42,000. Okay, from January to revenue from January to March. I got this. Now I'm going to remove this one and comment this. I want revenue that is greater than 1 lakh. Okay, so you can see I got these three revenue that is greater than 1 lakh. Okay, this one. And I'm going to print this, print revenue dot ilog from 1 to 4. Okay, so here you can say, you can see here from 1 to 4. Here I use slice. Okay, so from index 1 to 4, so from 95,000 to 1 2 3 4 88,000. Okay, so here I got this one. Okay, last last index would be exclusive. Okay, so from I need to take from 1 to 4. Okay, so this is give you from, this is 0 index, this is 1 index, 1 2 3. Okay, till 4, last should be exclude. Okay, so this is our output. I hope you got it. And monthly revenue is, and its name is monthly revenue, and data types here you can see we have integer. Okay, so here, so in pandas you can see here, use label when you want, meaningful access. Okay, you can use label. Use positional waste. Okay, use position when you want strict indexing. Okay, when you want strict indexing. And you can see here, use boolean. Okay, use boolean mask when filtering the data. Okay, and use ilog when you want clean positional control. Okay, use boolean when use boolean mask when you filtering the data. Okay, here I use boolean mask, this one. Okay, when you are going to filtering mask, then you can use this boolean mask when you filtering the data. Okay, I when you use ilog when you want clean positional control. Okay. Okay, guys, so most real world analysis, it's just combination of these four access patterns. Okay, one, two, three, four. Okay, if you understand this properly, okay, if you understand this properly, basic, you can say I'm not beginner now. Okay, so I'm going to move after this here. Vectorizing operation by pandas is fast. Okay, apply a 10% of growth projection, no pandas loop instead. Okay, so here we are going to vectorize the operations. Okay, so first I need to create one variable. What is it? Projected equals to revenue. Projected equals to revenue. Revenue, that is multiply with 1.10. What is the meaning of this line? Okay, I will tell you 1 minute. Wait a minute. Actually, I want to write fast. Here I'm going to put this one here. Okay, after this we have one comment in this month over growth. Month over growth. Okay, growth in percentage. Okay, so mom's growth, mom growth. Mom growth equals to revenue dot pct. What is pct? Do you know pct change? I hope you don't know. No problem, I'm going to explain. 1 minute, wait a minute. Okay, and after this I can print this mom growth. Mom growth. Okay, no, I can't print like this. I need to print hyphen, sorry, slash m, and here I need to print mom growth in percentage. Okay, and I'm going to print again, print mom growth dot round, and round is 2. Okay, and here we have cumulative revenue. I'm going to print Here I'm going to print cumulative revenue. So this is our cumulative revenues. So how can I print? Revenue dot cum sum means cumulative sum. Okay, let me show you why we create these lines. Okay, so first you can see here we have mentioned these two lines. Project equals to revenue into 1.10. So I'm going to apply a 10% growth projection. 10% growth projection. Okay, pandas apply this to every value at once. Okay, so I'm going to multiply in every value. Here you can see we have this one. I'm going to multiply this with 1.10. Again I'm going to multiply with this 1.10, multiply with this 1.10. Okay, so I have these revenues. I'm going to multiply with 1.10 here. Okay, so apply a 10% growth projection. Pandas apply this to every value at once. Okay, and we print this one. Okay, so after multiply, okay, I got this here. So here you can see we can multiply like this. Okay, this is simple multiplication. Okay, we have 12,000, I mean 1 lakh 20,000, 1 lakh 20,000. Okay, so it is going to be multiply here. Okay, with 1.10. It's like growth. Okay, growth 1.10. Again I'm multiplying 95,000 with 1.10 like this. Okay, and print the projected. So you can see I got this output. Okay, this one 32 13, I mean 1,32,000. Okay, and for February I have this output. March for this, after applying one, after multiply 1.10. Okay, after multiply 1.10 I got May data like this. Okay, okay, so here you can see I use in this line month over growth. Okay, so mom growth. Okay, so PTC change, what does it mean? Percentage between percentage change, it means what? I can mention here, it is a what? Percentage change between current and percentage between current and previous value. Okay, so it is a percentage between previous and current value. Okay, this calculate month over month. This is the percentage change between previous and current value. Okay, percentage change between current and previous value. This calculate month over growth. Okay, mom means month over growth. This is used to calculate month over growth. Mom equals to month over growth. I can write here mom. What is mom? Mom means month over growth. Month over month growth. Month over month over month over month growth. Okay, that is mom. Okay, so you can see here PCT. I already show you PCT change. This one change, percentage change between current and previous value. Okay, so we have revenues and we are going to find out at PCT and multiply this with 100. Okay, so we got this. and it is going to print the mom's growth here. This is a mom growth. Okay, and it is going to print the mom growth dot round to. Okay, so here you can see first value become the none here. Okay, first value become the none because there is no previous month to capture. You can see here we have first value. Okay, first value is none here. This one you can see first value is become none because there is no previous value, previous month to capture. Okay, because we have this month and here we have previous value of this, but we don't have any previous value before this. Okay, so that's why it is none. Okay, you can see PCT means percentage change between current and previous value. Okay, and now after this we have come sum, or here we print by using this we print the, you can see here we print the mom growth value round to. Okay, rounded to means decimal place for readability. Two means decimal place. You can see here we have two place. I mean we use two here, two here. Okay, so print mom growth. Here we are going to print mom growth. Okay, print the mom growth value rounded to decimal place for readability. Okay, now we are going to find out the cumulative sum. Okay, so come sum. You can see here come sum. I use come sum. Come sum is cumulative sum. Okay, so it will give you total, running total. Okay, so each value sum of all previous value including itself. Okay, each value equals to sum of all previous value. Each value equals to sum of all previous value including itself. Okay, each value means here you can see if I'm going to find out cumulative sum of this. Okay, this one. So each value equals to sum of all previous include itself. Okay, if you find out cumulative sum of this, then it will be 1 lakh to 200, sorry, 1 lakh 20,000 plus 95,000. Okay, this is called the cumulative sum of this. If you want to calculate cumulative sum of this, so you need to add all of these, I mean previous value, and again add this value also. So each value equals to sum of all previous value including itself. Okay, so it is giving you cumulative sum. Okay, here, where is it? Here. Okay, cumulative sum of every. So we have cumulative sum of February, this one. March we have this one. April we have this. May we have this. Okay, because we have none previously. So in March we have February and we have 90,000, 95,000. This one. In March we have 42 lakh. Now it will become this. In March, where is it? This one. So guys, you can see here we have got our cumulative sum, but I forget to put this here. Okay, so you can see here this is our answer, cumulative sum. Okay, first we have what? Cumulative sum. Okay, suppose we have this revenue. Okay, so first is 1,20,000 and second is for, I'm going to add this one too. I'm going to add both for calculate the February's cumulative sum, February month. Okay, so it will become like this, 1,20,000 plus 95,000. So it will become this one. Where is it? This one. Okay, I hope you got it. So this is our January, this is our February. Okay, so here you can see here cumulative sum. How can you find out this cumulative sum? So like we have data like this. No. 1 minute. Okay, so first thing, if you are like confusing here in mom's growth. Okay, 1 minute. Here I'm going to write code for mom's growth. Okay, if you are confusing here in mom's growth, okay, so this code is, I mean, this explanation for this one, mom's growth. Mom growth means month over month growth. Okay, so this is our this is explanation for mom's growth. Okay, so what is the mom growth? Current value minus previous value. I already mentioned this one. Here you can see PCT change means percentage change between current and previous value. Okay, so we have this one PCT change here. This one PCT change means current value minus previous value. Okay, and we need to divide it with the previous value here. So you can see we have some values in February and some data in January, and we need to divide with January. Okay, similarly we have March. Okay, and previous value of March, I mean previous month of March, that is February. Okay, then I need to divide with February, and then I'm going to multiply with 100 here. Okay, so you can see here in mom's growth. Okay, so you can find out like this. This is the function, that is I'm going to use mom's growth. Okay, so here you can see this is the, I mean, so not function, this is the variable mom's growth. Okay, so revenue, we have revenues, these are the revenues. Okay, 12, I mean 1 lakh 20,000, 95,000, 1 lakh 42,000, 88,000, 1 lakh 75,000. These are the revenues. Okay, so here you can see revenues. I'm going to find out the PCT changes of this revenue. Okay, and PCT changes, like you need to subtract current value, that is like we are going to find out for February. Okay, so we are going to subtract February with previous value, that is January, value of January, value of February, and divided by the previous value. Okay guys, so this is the formula of PCT change. Okay, suppose we have January equals to 10 and February equals to 120. Okay, so then I need to put this value, February equals to 120, January equals to 100 here. Okay, so 120 minus 100 divided by 100, so I got 0.20, 20% of this, 20% like this. Okay, so I have already mentioned this one here. Okay, so we can take revenues value, this one. Okay, so January we have 1 lakh 20,000 and February we have 95,000. Okay, so if I'm going to calculate for February month, so here you can write like this. If we have January equals to, so here for example, if we have January equals to 1 lakh 20,000, okay, and February equals to, we have 95,000. Okay, now I'm going to calculate PCT change. Okay, so we are going to subtract 1 lakh 20,000 with 95,000. Okay, and I need to divide it with the 1 lakh 20,000. Okay, so I got this, something like this. Okay, you can see here this one, this is for February month, mom's month over month growth. Okay, so I hope you got it. How can we calculate this? Okay, so this is like a rough idea I'm giving you for this one. Okay, so now you got this one. So here I'm going to print month growth round 2, means it will give you 2 decimal values here like this. So this is the result for mom growth. Okay, monthly revenue, and data type it is in float. Okay, and it's and you can see here cumulative revenue. So cumulative revenues is, for example, I'm going to calculate cumulative revenues. So how can we calculate cumulative revenues? So here I'm going to write cumulative, dry run for cumulative sums. Okay, I'm going to put a space here that it will give you everything in one line like this. Okay, now I'm going to write dry run here for cumulative sum. Okay, suppose we have January. Cumulative sum is like this. Okay, so initially, previously we have first previous column is none, so that's why January is none here. Okay, so here you can see, suppose we are going to calculate cumulative sum for January. Okay, so we have revenue, for example, we have revenue equals to 100. Okay, January, February, March, and its revenue is 100 to 100, 150. Okay, so here you can say January equals to, we have 100, so it will print cumulative sum of January, that is 100 only. Okay, for cumulative sum of February, it is going to print summation of January plus February. Okay, so I got here like we have 100 in January and 200 in February, so I got 300 here. Okay, similarly we are going to calculate for March, so January plus February plus March. Okay, so we need to add previous 2 month here and itself, so it will become 100 plus 200 plus 150, it will become 450. Okay, I hope you got it. How can we calculate this? Okay, so this is our cumulative sum. So these are our cumulative sum. Okay, I already explained here what is the cumulative sum. What is the cumulative sum? Okay, summation of previous. Okay, summation, like if I'm going to calculate for March. Okay, so summation of all these and plus itself. Okay, so we can calculate like this. Okay, now what I'm going to do, I'm going to move here. Now I have finished this essential series method. Use array in analytics. So after this, we have this one, essential series method, use every day in analytics. Okay, so first we are going to create a series of student. Okay, series of student, and I mean score including a missing values NP. Okay, so should I mention here? Maybe. Okay, no problem. So this is what I'm going to create, a series of student scores including a missing values. NP dot none. Okay, so you can see here I'm going to create a series of student score. Okay, so you can see here this is the series. Okay, and these are the scores of student. Okay, including a missing value, NP dot none. So I have one missing value, that is NP dot none. Okay, so what I'm going to do here, I can print here descriptive. If I have here descriptive sum, so here I'm going to print descriptive statics. It means what? This line's meaning, this one, it is a printer section header for readability in output. And I'm going to print score. I'm going to use this score dot describe. So why we are going to use describe here? Describe are used to generate the summary. I mean here we are going to generate the summary of statics like count, mean, standard deviation, minimum, quartile, and maximum. So it will give you the summary of your data. So I'm going to run this. You can see here I got this descriptive statics. Okay, so first this line we got here. Okay, and with the help of this describe, we got description of this data. Okay, we have count, that is 9. Okay, you can see here 1 2 3 4 5 6 7 8 9. Okay, so we have 9. Okay, count 9, and mean, what is the mean? We are going to calculate here mean. I mean it is also giving the mean. Mean means average of this. Okay, and we also calculate the standard deviation, also calculate the minimum value. What is the minimum value of here? So we have 60. Okay, and percentage of, I mean per 25 percentage, that is 75. Okay, 25% of this we got 75, and 50% of this we have we have 88, and 75% of this data we have 95, sorry 91, and maximum value what is it, this is 95. Okay, and data type is float here. Okay, so describe will give you full summary report here. Okay, so that's why we use describe. And after this we use what, calculate the average. Okay, so first maybe I have calculate the average. Okay, so we can calculate by using this. I'm going to copy these things one by one. I'm going to calculate average here. Okay, so I mention in heading, I'm going to calculate average. Okay, and here I can also mention this line here. Okay, so here I'm going to calculate of average. Okay, average will give you what, mean is giving us average, so scores dot mean. Okay, so I use float, so that's why I need to write 2f here. So here you can see I got this mean, that is average. Okay, again what I'm going to calculate, I'm going to calculate this one, calculate the median, sorry. So here I can calculate the median. Okay, so you can see here median, calculate the median means middle value after sorting. Okay, so I'm going to write middle value after sorting. Okay, first you need to do sorting, then it will give you middle value. Okay, I mean it is going to sort automatically, we don't need to do sorting. Okay, after sorting it will give you middle value by using median. Okay, or it may be in float. So if I'm going to run this, so I got median value, this is our median value. Okay, middle value, this one after sorting. Okay, and again I'm going to find out next thing, that is what, mean, median, standard deviation, this one, and mode also. I can copy these two things and paste it here. Alright, oh, why I'm here, here we are going to print standard deviation and score dot mode. Okay, so calculate the standard deviation. Calculate the standard deviation means spread of the data around the mean. Guys, I hope you already know what is the standard deviation. Okay, so standard deviation means standard deviation. So here I need to write spread data around mean. Okay, and mode, again I'm going to next I'm going to print mode. What is the mode? Find the most frequent value. Okay, most, it will give you most frequent value. Okay, it is used to find the most frequent value. Okay, with the help of mode. So here if I have 0, it will pick the first one. Okay, I mean like we have different multiple, I mean we have different multiple values here. Okay, like you can see here most frequent 88 coming multiple time. Okay, maybe another value is coming also multiple time. Okay, but it will give you first one. Okay, like we have 75 also in multiple time, so first it will find out that is 88, so it will return like this. Okay, so here I need to write comma, what is the meaning of 0? Okay, it picks the first 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 mode if multiple exist. So I'm going to run this. So you can see standard deviation is 1 point, sorry, 11.61. Okay, so standard deviation this one, and mode is this one, 80h coming multiple time. Okay, most frequent value. And after this, what I'm going to print, so here let me explain again. Okay, so this one describe are used for full summary. It will give you full report. Mean, medium, standard deviation, or mode. Okay, these are the individual state breakdowns. Okay, and now I'm going to use value count. So where is value count? I'm going to write for code for value counts. So where is the value counts? This is our value counts. Okay, so here value counts critical for categorical analysis. Okay, so here we are going to count the values. Count how many time each unique value appears. So should I mention here how many times each unique value appears? 1 minute. So you can see here this line, print a new section header for the frequency analysis. Okay, so here I'm going to write for this. Okay, so this one is used for the count how many time each and unique value appears. Okay, so it will count how many times so here I print score dot value underscore count, so it will count how many time each value appears. Okay, how many time each value appears. So 88 come 3 times. Okay, you can see here 88 present here also, here also. Okay, so 88 present here 3 times, 88 appearing here 3 times. Okay, 91, 92 one time, 75 one time, 95 one time. Okay, all of them one time except 88. Okay, so here it will give you the count count how many time each unique value appears. Okay, again we have this line. So here we are going to print. Okay, so print null check. Okay, here I'm going to check the null, print the null check section header. Okay, so I'm going to print null, and here score I'm going to use is null dot sum. So is null will give you none value. So here I'm going to count the missing value. Okay, so here I'm going to count missing values, that is called the none, and none. Okay, and none missing values. And none missing value. Okay, so score dot is null dot sum, it is giving you none values, and this is used for this line. It will give you sum of not none, and means none missing, not. Okay, it will give you none missing values and none missing values. Okay, I'm going to write code here. So you can see we have null values, that is 1. Okay, because we have this none. Okay, this line is used for giving you null values. Okay, score dot is null is used for find out the null values. Okay, missing values. So I got 1 with the help of this. Okay, With the help of this, I got one value, null value, and none null. So it will give you none null values. Okay, none null, that is not missing. Okay, so score dot not na, I'm going to use not na, that is not missing. Okay, it's sum. So I am going to find out the values count that is not missing here. So it is 9. Okay, we have none null values 9. You can count here. You can see here 1 2 3 4 5 6 7 8 9. 9 values are present here, that is not missing. Okay, so that's why I got none nulls 9 and nulls is 1. Okay, I hope you got it. Okay, now we are going to write code for this here. Okay, so here we are going to check data quality check. Okay, it is mandatory if you are using real project, real data. Okay, if you are doing some real project. Okay, so now I'm going to write code for this. So here I have finished this one. Okay, here I use these thing to print. Okay, I print mean, median, standard deviation, more. Okay, and here I have completed MOM. So what is the MOM? MOM means we are capturing each month with the previous month to see the growth or drop. Okay, so here now we are moving here string series. Okay, so string series means what? So I'm going to create one series here. First, string series means we are going to create one series using the string. Okay, so here I'm going to create this series. Okay, customer equals to, this is the variable name, customer equals to pd dot series. I'm going to create this series. Okay, here I have everything in string. Okay, name is Alice, Bob, Charlie Brown, Bob Smith. You can see here, these are the data of customer: Bob Smith, Charlie Brown, Diana Prince, Eve Williams. Okay, so this is our string data set. Okay, so very common with customer data. So we have this one. Now I'm going to do what? I'm going to clean name like a real ETL. Extract transform load. Okay, I'm going to clean name like a real ETL pipeline. So here I have one line to clean this. How can we clean? We are going to use this to clean the name like ETL. Extract transform load. Alright, where is it? This one. Okay, so here I'm going to clean customer underscore clean. Okay, this is the new variable, is equals to, I'm going to pass here customer, this one. Okay, I'm going to use dot str for string. Okay, dot strip, so it will use to remove the leading high, I mean slash trailing white space. It is used for remove the white space, like we have here a space, this one. Okay, you can see here we have a space here. Okay, again we have another space here, this one. Okay, so this one is used for remove the white space. Okay, and here you can see here str title. Okay, str dot title, so convert the proper case. Okay, like we have this one. Where is it? This one, Alice John Dew. So it is going to convert like John Dew equals to John. For example, we have this one. I'm giving here one example. For example, we have what? We have Johan Dew. Okay, so it will convert like this. Can say like this. First J is capital, Johan, and D is capital. Johan Dew. Okay, so here J is capital, sorry, J is in capital letter, Johan. Okay, so with the help of this, with the help of string dot title, we got proper case. Okay, like this, it will give you proper name. Okay, we have Johan Dew, it will give you like this. Okay, so convert to the proper case, Johan Dew, convert like this. Okay, and after this we have another line, str dot replace. Okay, so it will replace a multiple space with a single space. Okay, so here I'm going to use a r. Okay, I use single quotes, okay, and slash s. Okay, so here I'm going to replace multiple space. Okay, so replace multiple space with the single e billions. Okay, I'm giving one example, like if we have a multiple space, for example, we have one string like this, Eve Williams. Okay, then like we have multiple space here, we have one more space, for example here. Okay, in this line, okay, we have spaces. Okay, so it will remove this space, it will give you like this, Eve Williams. Okay, so that's why we use this line, so it should also in double quotes. Okay, so I'm going to cut this and paste it here. Okay, so like if you have Eve Williams, here we have multiple space, space. Okay, so it will give you like this. Okay, and regex equals to true, regex pattern. I hope you already knew about this. Okay, and we are going to print the clean customer data. So here with this variable customer underscore clean, so I'm going to run this. Okay, so you can see here I got proper name, customer data. You can see alias Johan, we don't have any space here, Bob Smith, Charlie Brown, Dinah Prince, and Eve Williams. Okay, and data type is in string. Okay guys, so this is our string series. Okay, I use series to convert into a string. Okay, now you can see now after finishing this, okay, I'm going to create another code here in this cell. Here we are going to write code. I'm going to use apply. Okay, and then lots of things. So I'm going to print customer first thing. Okay, print customer clean. So here I'm going to print this customer clean. I got this one. Okay, so I can also print name, first name of customer, and other thing I'm going to show you here. So here I'm going to print the first name. Okay, like we have Elias, Bob, Charlie, Dinah, Eve. So it is giving you first name. Okay, you can see here we got first name. And in customer clean dot split, if I'm going to remove this, I'm going to comment this one. Okay, so here it is giving you like this, first name. Okay, with this line we got this first name. Okay, but I want the first name from the customer table. Okay, but we have customer data inside this, customer underscore clean data. Okay, customer underscore clean, so I use this one, customer underscore clean. Okay, so here after removing this customer underscore clean, we have any strings. Okay, and it will strip and it will give you first name str 0. I means it will give you 0 index. And what we have at 0 index, Alice, what we have at 0 index, Bob, what we have at 0 index in this row, Charlie, in this row what we have, Dinah, in this row what we have at 0 index, Eve. So it will give you what we have in row at index 0. So I got this Alice, Bob, Charlie, Dinah, Eve, and its data type is object. Okay, so I hope you got it. Okay, so after this 1 minute, it is going to print the first name from the full name. Okay, and this one split the full name into a list and pick first element of first name. Okay, after this I'm going to write 1 minute. I already finished. Actually, I did mistake maybe. Okay, so here this is for only this table. Okay, we can print here. So it is giving you clean data and first name. Okay, this is our first name from the customer underscore clean table. Okay, I'm just doing what I'm just going to paste these two line. Okay, before I have these line here. Okay, so now I have finished this. I'm going to continue with here. Okay, now you can see here I'm going to move here. Okay, apply method when vectorized method aren't enough. Okay, so apply method means we are going to use apply. So let's you run a custom Python function on each element of a series, but it is slower because it works row by row. Python level loop hidden inside this. Okay, so I'm going to show you how can it work. Okay, so first thing I need to create one series. Okay, so this is the series revenue underscore series pd dot series. Okay, I'm going to create one function. This is function name. Okay, so here I'm going to write function name. Here I'm going to use this function define underscore classify, sorry, define classify underscore revenue, and I'm going to pass here values. Okay, values. So here I can see here why we use this function. It is a custom function to classify revenue into business category. So I need to write here, this is custom function to classify revenue into business category. Okay, custom function to classify revenue into a business category. Okay, so this is the function name classify underscore revenue. Here I'm passing the values. Okay, so you can see if value is greater than 1,50,000, it will return the high. Okay, if value is greater than 1,50,000, it return the high. If else if else value is greater than 1 lakh, it return the medium value. Okay, otherwise it will return the low. Okay, below 10k, low segment. Okay, so I need to write here below, not 10k, 100k, that is low segment. Low segment. Okay, and here this is our medium segment in between 100k to 149k. Okay, this is called the medium segment. And this one is high. So if we have greater than equals to 150k, so it is high segment. Okay guys, so we have more than 150, I mean 1,50,000, it is high segment. And this one is for medium and this one is for low. Okay, below 100k is slow segment. Okay, so after this I'm going to apply what? I'm going to use apply approach. So here I'm going to use apply. Okay, so here you can see I'm going to use apply. So revenue underscore this series, I'm going to use this apply, and inside this I'm going to pass this revenue classify revenue. Okay, and this is taking this series. Okay, element of this series like 1,20,000, 95,000. Okay, like this one by one, and check here if it is greater than 1,50,000, it return the high. If it is has, I mean if it has any value that is greater than 1 lakh, it will return the medium. Okay, otherwise it will return the low. Okay, if I'm going to print this, you can see here. Okay, 0 is low. First one at index 0, what we have? Low. Okay, medium. This one is medium because it is greater than 1 lakh. Okay, you can see here we have 1,20,000 that is greater than 1 lakh, so it is medium. Okay, index 1, what we have? 95,000. You can see here 95,000, I mean less than 1 lakh, we have low. Okay, low segment. Again you can see here I have 1,42,000. This is come in the medium because it is greater than 1 lakh. Okay, again we have 88,000. This is also low. Okay, because it is below the 100k. And I have 1,75,000. It is also high because it is greater than 150 and 1,50,000. Okay, and data type of is string. Okay, so that's it. I mean, just we are going to categorize that what is the high and what is the medium and what is the low. Okay, so these are the string: medium, low, high, whatever. Okay, so its data type is also string here. Okay, and we can also use this better way. Here you can see we are just I mean applies the classify revenues here. Classify revenues here function. So applies the classify revenues function to each value in the series. Okay, so that's why we got this medium, low, high, whatever. Okay, and I can use this one. Okay, this is for vectorize and this is also fast. Okay, better way pt dot cut. Okay, so in place of these I'm just going to use pt means pandas, I'm going to use cut. Okay, so if I'm going to print this, I got this answer low, medium. 1 minute, so I need to write this separately. I can write this separately here. Okay, so with the help of pd.cut, and here I'm passing this revenue series, this one. Okay, and I got, and I'm passing here in bins 0, 1 lakh, 150 and float infinity. Okay, means till the infinity. Okay, so here I got level also. You can see here levels. These are the levels: low, medium and high. So it will categorize like this. Okay, first one is medium here. This is low. One is low. Okay, so you can see here first one is 1,000, I mean 1 lakh. Okay, that's why it is medium. And second one is we have 0, 1, 2, 3. you can see here categories 3 string low. 1 minute. So here you can see I got this output after running this. I'm using here cut. Okay, so you can see here I got 0 first. This is a 0. Okay, first this one is for 0, so it means it is giving us medium. So here you can see I have from 0 to 100k. Okay, that is categorized as low. Okay, in between 0 to 100k, that is low, and in between 100 to 150k, that is medium. Okay, so this is medium, and in between 50k to infinite, that means it is high. Okay, so at index 0, what we have in revenue series? Okay, so before we have revenue series, this one, this is our revenue series. This one. Okay, so at index 0, what we have? We have 1,20,000. Okay, and second we have 95,000. Okay, so you can see this is our revenue series. Okay, so what we have at index 0? We have 1,20,000, means it is medium. Okay, because it is coming here in between 1 lakh to 150 lakh. Okay, so this is the medium. Okay, now we are going to check at index 1. We have low. Okay, at index 1, what we have? Low. Okay, so we can see here we have at index 1 95,000. Okay, 95,000 is a low. Again we have medium. We have 1,75,000. This is for high. Okay guys, so we can categorize like this: low, medium, high. Okay, so here you can see start with 0,000, 1,50,000. Okay, so our output become like this: medium, low, and high. Okay, this one, this is not, this is not a number anymore. This is like categorical data: medium, low, medium, low, medium, low, and high. Okay, so here you can see convert numeric revenue into a category using bins. Okay, so it is used for vectorize and no loop. Okay, so here we don't use any loop, we just use cut, and it is just categorize this data: low, medium, high level. Okay, and if you want to print something, there is this, no, I don't have. Or you can also find out its cumulative sum like this also. Okay, January it's data for January plus February. Okay, if you are going to find out cumulative sum for February, so it will become by adding previous one and by adding the itself, its own data. Again we are going to find out cumulative sum for March, so it will become by adding both of them, January and February, and then we are going to add this. Okay, so it will become this one. So this is called the cumulative sum, cum sum. Okay, so you can also print the cum sum also here. Print cumulative sum of revenue series. Okay, so here we will print our cumulative sum revenue. Revenue dot cum sum. Okay, so we got this one for our revenue, and if you want to print this one, so it is giving you like this, similar. This is revenue. Okay, so now you can see here I got categorized, I got data in a string, or we can categorize data in medium, low, high. Okay, so you can see I already categorized the data. Okay, so guys, one more thing, I'm going to comment this one. Okay, come some, there is no need for come some. Okay, so I use bin here. Okay, this is like categorize the data. 0 means low, and 1000 means 1 lakh means medium. Okay, and 1,50,000 means, so it is here we are going to categorize from 0 to 1 lakh. Data is, from 0 to 1 lakh it is low, and from 100, from 1 lakh to 150 lakh, that is medium, and 150 to float infinity, it is infinity. Okay, that is high. Okay, so this is going to categorize. Okay, so this one is low, from this to this low, and this to this medium, and this to this high. Okay, so it is going to categorize by using bins. Okay, and you can see I have 1,20,000. Okay, 1,20,000 in revenue series first, so it is medium, so it is giving you medium here. Again we have 95,000. Okay, so we can check 95,000 here, so 95,000 come under this, so it is low. Okay guys, again we have 1,75,000. Okay, or whatever we have, so it is medium. Maybe after, this is for high, so maybe what we have in revenue series. Okay, so I go according to get our result here. Okay, medium, low, high, and category. Okay, and you can see here 3 category equals to 3, and it should be in string. Okay, so we have medium, one is medium, low, and high, so these are 3 categories in string. Okay, low is less than medium, and medium is less than high. Okay, so we are going to use this one. I hope now it is going to clear. So now I have finished my module 2, and we can see here apply. Before we use apply here, this one apply. Okay, so apply means it is giving you slow result. Okay, slow run function on each value, because it is going to run function each value. Okay, and I'm going to use, I already use here pd.cut. So this is fast and run on whole array. So apply is manual, apply is like a manual labor. Okay, applying one by one for each function or each value. Okay, and this is like automation. Cut is like automation. pd.cut means automation. Okay, so pd.cut categorize in 3 category: low, medium, and high. This one. Okay, and I already use comes on, it will give you total numbers. Okay, so both are completely different, pd.cut and apply method. Okay guys, now I have finished this module. Now I'm going to write code for module 3. Okay, so see you in next module. Bye bye, take care. Hi everyone, welcome back to my channel. In this video we are going to learn one of the most important tool in data analysis, the Pandas DataFrame. If you are ever work with Excel or SQL table, a data frame is basically the Python version of that, but way more powerful. By the end of this video, you will know how to create the data frame and explore and understand your data, select and filtering data like pro, and perform real world operation step by step. Okay, so in this video I'm going to cover what? So I'm going to cover create a data frame, inspecting data, selecting and filtering the data, modifying and sorting, and writing clean pandas code. If you find this helpful, make sure like, subscribe, and comments in video. Okay, so now I'm going to write code for this. So guys, I'm going to start module 3 data frame .ipynv file. So here I'm going to write code for data frame. So what is the data frame in Pandas? Data frame is like a 2D table. Okay, it has row and columns like Excel sheet. This is the most used structure in Pandas. Okay, like we have table, and inside this table we have row and columns. This is called the data frame like table. Okay, so in real world project we usually load the data file like CSV and Excel or database. Okay, so using function like read underscore CSV. Okay, with the help of this we can read the CSV file, and read underscore Excel. We can read Excel file by using this, and read SQL underscore SQL. We will read the SQL file. Okay, and read the par quit. Okay, but we will read files by using these commands. Okay, but here instead of loading data we are going to create our own data set. Okay, so this is called the synthetic data or fake data, but realistic data used for learning. Fake but realistic data used for learning purpose. Okay, so I'm going to use here np.random.seeds. Okay, so seed set the starting point for the random number generation. Okay, this is the starting point for the random number. I'm going to use 42. I mean, I'm going to use this for a starting point for the random number generation. Okay, so why we use seed without seed, every runtime, okay, if you are going to run, it will give you different data. Okay, and your output chain confusion chaos and mild I mean you will get confused. Okay, so with the help of seed, same time every same date every time, easier to debug and easier to teach. So that's why I'm going to use seed. Okay, seed 42. So first thing I'm going to import here, so I'm going to start code here. So first I'm going to imports numpy. Okay, numpy, import numpy as np. Okay, and so here I'm going to use numpy as np, and I'm going to use pandas, import pandas hpd. Okay, and now I'm going to write np dot random dot seed 42. Okay, setting a random seed ensure that we will get the same random data every time we run the code. So this function help with the reproducibility. Okay, so I'm going to setting a random seed ensure that we get the same random data every time we will run the code. So this will help for the reproducibility. Okay, so here I'm going to take number equals to 200 also. So number equals to n equals to 200. Okay, so number of row record in our data set. This is the row, number of row, n equals to number of row. So I'm going to change my kernel. Guys, if you have virtual environment, you can use your virtual environment here. Okay, so after this, okay, after this I'm going to create what? I'm going to create I'm going to create data frame. Okay, so I'm not going to create by manually, I'm just copy and paste here. Okay guys, I already have data frame. Okay, so df equals to pd dot data frame. We can create data frame like this. Df equals to variable name, and pd means we are going to use this pandas and data frame. Okay, so we have this inbuilt data frame method. Okay, inside this in dictionary I'm going to create. Okay, so first I mention the order id. Okay, these are the columns order id. Okay, and we are going to take order id in between range from 1001 to 1001 plus n. We have n equals to rows. Okay, so unique id or unique order id for each order. Okay, so range start from, this is for start and this is for end. Okay, this one is for end, 1000 plus 1. Okay, so this is called the starting point, where unique id should start from here and end here, 1000 plus 1 plus 1001 plus n. Okay, so range start, inside the range we have start and end, so generate the sequential number. Okay, again we have customer id, guys. Okay, so customer id, you can see customer id np dot random dot rand int. Okay, so random number between 100 and 159, because I'm putting here inside this rand int, it is going to take integer, guys. Okay, rand int. So these are the np dot random, means with the help of random is inbuilt, it will give you random number. Okay, with the help of rand int, so we are going to take integer, so that's why it is here rand int. Okay, so here you can see I pass here 100 and 160, so this is the starting. Okay, so random number, it will give us random number between 100, so we have 100 and 159. Okay, okay, last should we exclude, and we have n means row. Okay, so after this we have product name randomly selected from a list. Okay, so we have product name, this is also our column name, guys. These are the column names: order id, customer id and product. Okay, so here you can see product name randomly select from the list. Okay, so np dot random, and choice also give you the random product name. Okay, so it is here I'm going to pass laptop, phone, tablet, monitor and keyword. Okay, so product name randomly selected from this list. Okay, so that's why I use choice. So np dot random dot choice, so it will give you product randomly by using this list. Okay, and you can see here I have another variable, that is category. Okay, so I use this category, so it will define the product category. It may be electronics or it may be peripherals. Okay, so here you can see category np dot random dot choice. Okay, again I'm going to use choice for categorical data. So you can see here it is going to categorize in electronics and peripherals, or here this is the row, number of row, and means number of row. So it is giving us product category. Okay, in every row, and quality of item per order between 1 to 5. Okay, this is another column, quality. So np dot random, it is going to use rand int, because we want in integer, so that's why I use np dot random dot rand int. Okay, so it will give us in between 1 to 5, because it has 1 to 6. Okay, so last should be exclude. Okay, and here I'm passing n. So quality of item per order. Okay, n means row, here I just pass the row. Okay, so price of the single unit, random float between random price of single unit, random float between 50 and 2000. Okay, so unit price equals to np dot random dot uniform. Okay, so we are going to use unit price, I mean uniform price of single unit, so that's why I mean it is giving us price of unit, I mean single unit. So it is going to use float in between 15 and 50 and 2000, and here I am going to pass n, and here I use round. Okay, so it will give you a number in two round, like we have maybe we have like this. Okay, 2.50 like this. Okay, so it is giving us two round. Okay, also like this, it is giving you like this. Okay, two round means it is giving us two number, then we have decimal. Okay, so price of single unit, random float between 50 to 200. Okay, so with the help of this we are going to calculate price of single unit. So np dot random uniform. Okay, so you can see here this is giving us numpy what is the np. Okay, and here we are going to use random, so you can see here why we use random number. Okay, and this is the uniform, guys. Okay, It is doing for uniform distribution. Okay, uniform distribution means you need to pass low, I mean, you can see here low and high. Okay, data sample for the uniform distribution. So sample are uniformly distributed over the half open interval low and high. Include low but exclude the high. Okay, in order where any value within the given interval is equally likely to be drawn by the uniform. Okay guys, so it is going to use these range. This is for low and this is for high uniform. Okay, and it is giving us answer in the float. That's why we use round to. Okay, now you can see discount percentage apply to the order. Okay, this is the another call. This is the another thing, discount percentage of the column. So np dot random, I again use choice. Okay, so you can see here choice. Okay, you can see here why you are going to use choice. This is give us random number. If you learn Python, if you already know Python, then you will get it. Okay, what is the choice, what is the random, and you can see here generate a uniform random sample from np dot range 5. Okay, so it is giving us random sample. Okay, generate a uniform random sample. Okay, so that's why we use choice here. Okay, so it will generate the uniform samples, random samples. Okay, here I pass the n, and you can see region where the order was placed. Okay, so np dot random, I use choice again, or it will select the, I mean, regions from this list. Okay, and here it is going to select number randomly from this list. Okay, and again I use this cells underscore rep, cells representative handling the order. So np dot random dot choice, again it is going to select from this list randomly. Okay, and I have passed the number of row. So order date is starting from January 1 and 2024. So generate the sequential date. So order date equals to PD, I mean order date colons PD date underscore range. So it is giving us date range. Okay, from 2024 01 to 0, sorry, 0101 period and frequency. Here I am passing D. Okay, and here I am passing row, number of row from 0 to n, because I have already 200. Okay, now guys, this is our data. Okay, I hope you got it. How can we create data? This is the synthetic data. So guys, you can see I use here period n means 200 dates. Okay, it will give us 200 date, and frequency means daily frequency. Okay, so should I put it in comment? Yes, if you have doubt, I can put it into a comment. Okay, period n equals to means we create 200 date, and frequency d equals to daily frequency. Okay, so now it is going to clear. Now I have code here inside this. Okay, I'm going to use this. Okay guys, so here you can see I'm going to use this. So what is the meaning of this? Okay, so here I'm going to calculate revenue. Okay, df revenue, df, and column name is revenue. Okay, so I'm going to calculate revenue. Okay, and revenue equals to, we have quantity. Okay, what do we have? Quantity like this. Okay, so you can see here, maybe I have I can write here. So revenue equals to I have quantity quantity into price, quantity into price, guys. Okay, I mean quantity into unit price or price into what? Quantity into price into 1 minus 1 minus discount. So guys, this is the formula for calculate the revenue. Okay, you can see here we have revenue equals to quantity into unit price into 1 minus discount divided by 100 and round equals to 2. Okay, so this one, this is the total price. Okay, this is the total price. I already mentioned here, this is the total price. Okay, total price, and we have this one, this is the applied discount. Okay, so this is the total price and this is the applied what? Discount. So we can also write like this: revenue equals to total price, revenue equals to total price, revenue equals to total price, and this is the discount, applied discount. Okay guys, this one is a, this one from here to here, discount. Okay, and round to means just round it to the 2 decimal place. Okay, we just want 2 decimal place, so just rounds it to the 2 decimal place. So this give us the final amount the customer actually paid. Okay, so revenue equals to total price into discount. Okay, so revenue equals to, this is the formula, quality into price. This is going to calculate the total price of quantity. Okay, if we have 200 quantity, I'm going to multiply with the price, and after this I'm going to apply the discount. Okay, and I want round 2 decimal place answer. Okay, so after this, actually I got this. Now I'm going to print the shape of this. Okay, so you can see here we have quantity, this one, I use this quantity. Okay, and I have unit price. Where is our unit price? Inside this we have unit price, this one, this is unit price, this is the quantity, and this is the unit price, guys. Okay, and discount PCT, where is it? This one, discount percentage applied to the order. So I'm just taking these parameters, or we can say these variables, to calculate the revenue. Okay, and revenue is calculated as quantity into price, quantity into price. Okay, and then we subtract with the discount. Okay, so formula is this one, this is the formula. Okay guys, so now we print the shape of the data set here. Okay, shape tell us how many rows we have. Okay, and how many columns we have. Okay, it's so like we have 200 row, it is giving us, like we already mentioned, 200 row and 11 columns. Okay, that means we have 200 row and 11 columns. Okay, and head, I use head equals to 5. This means this will show you first 5 row. Okay, head 5 means first 5 row. If you mention here in place of 5 10, then it will give you first 10 rows. Okay, if data look correct, if column are correctly, I mean if column are created properly, okay, then it will give you first 5 rows. Okay, so I'm going to save this, I'm going to run this. Okay, so you can see here I got my data frame. you can see here I got this order id, then customer id, then product, then category, quantity, unit price, discount, region, and sales representative. Okay, so you can see here order id, customer id, product, category, quantity, unit price, discount, region, sales price, order data, and revenues. These are the revenue. I have created revenue column by using this. Okay, so this is the column name revenue. Okay, so I'm going to use quantity multiply with the price. Okay, and multiply with the unit price. These are the unit price. Quantity, this quantity is going to multiply with this unit price. Okay, and then we have discount pc, so I'm going to subtract discount pc with, I mean, with -1. Okay, and then multiply into the quantity, into price, into the discount after subtract 1. Okay, so then it will give you revenue here. Okay, and we are going to save here this one. So it is giving us 200 rows. Okay, you can see here 200 rows and 11 column. Okay, and df dot head, it is giving us 5 first row. Okay guys, so this is our data frame by using pandas. I hope you got it. Okay, so we generate dates using daily frequency. Okay, here, and we calculate revenue using quantity, price, and discount here. Okay, we check the save here, and we check save to see the data set, I mean data set size. We use head here. Okay, to preview the data. Okay guys, this is our data, look good. Hmm. I hope you understood this data set. Okay, now I'm going to create something. Okay, so here this is the first thing you should do with any data set. Okay, so I'm going to use essential inspection method. Okay, this is the first thing you should do with any data set. Okay, so before analysis, always understand your data. Okay, so here I'm going to paste it. Okay, so essential inspection method, first thing you do with any data. Okay, here I use shape. Okay, so we can check print df dot shape. Okay, so shape return a tuple, number of rows and number of the column, like this. Shape is return tuple, number of row and number of column. Okay, and help us to understand data set size. Okay, and you can see here I'm going to print information df dot info. So it is giving us what? So info give us column name. Okay, D- column name and data type. Okay, but and data type, like you have integer, floats, object, data, date and time. Okay, etc. So it is giving us column name, data type. Okay, and null, you can see here null count, null count. Okay, so non null counts to check the missing value. It is giving us missing value also. Okay, and very useful for cleaning the data. It is very useful for the cleaning the data. It is giving us the information, column name, okay, data type. Okay, and count the null values. Okay, with the help of this. And we use describe. Okay, so describe, it is used for giving the summary. Okay, so it is giving us the summary, or we can say statistical summary for numeric column. Okay, so suppose we are going to calculate the mean, standard deviation, minimum value, maximum value. Okay, so round to just format the number to decimal place. Okay, so I use round to just format number to the decimal place. df dot describe dot round, it is give the summary. Okay, and here you can see here categorical column. Okay, so with the help of this df dot describe, here I pass the include equals to object. You can see here, before I haven't passed here. Now you can see here include equals to object. So here include equals to object is used for categorical text column. Okay, it's so what, count number of the values. Okay, unique number of unique category. Okay, and top most frequent value, and frequency of the top values. Okay, so I'm going to run this. Oh guys, I got error, name is not defined. Oh, 1 minute, I need to remove this line from here and I can paste it here. Okay, I'm going to run this. So first output, save the data. Okay, so it is giving us save the data. Okay, like we have 200 row and 11 column. And second, we have information, this one, this column. Okay guys, so it is giving us information pandas.dataframe. It has class pandas.dataframe. Okay, random, I mean range of index 20 100 200 entries from 0 to 999 199. Okay, because we are going to use 200 rows. Okay, and data column, it is giving us the column of data. Okay, so these are the columns: order id, customer id, product category, quantity, unit price, discount, pct, region, sales, rep, and order date and revenue. Okay, so this is giving us column name and data type. Okay, so we, you can see here data type, this is order id is integer. Okay, customer id is also integer. Product should be in string, product and category also in string. So guys, this is the data type: float, integer, string, and date time. Order date, its the data type is date time. Okay, and this is also float. Okay, so you can see here it is giving us data type. We use date time, float, integer. So we have one date time. Okay, and we have two float 64 and we have integer 32, that is 2 integer 64, I mean integer 64 bit. Okay, and string, that is 4. Okay, and memory uses 15.8 kb. Okay, and this is going to describe the summary. It is also going to describe the summary here. Okay, so it is also giving the non null count. Okay, 200, we have 200 row in order id, but we don't have any null value. Okay, again here we have 200, but there is no null value. Okay, if we find out null, then it is also count here. Okay, and here you can see summary. In summary, it is giving us order id. Okay, so it is going to count 200, total count 200, customer id is also 200, quantity is 200, unit price 200, discount price 200, order date 200, and revenue is also 200. Okay, because we took n equals to 200 there. Okay, then we are going to calculate mean. This is the mean of customer id, quantity, unit price. Okay, and we can find out the minimum value. These are the minimum value: 25% of order id, 25% of the customer id, 25% this is the 25% of the quantity, 25% of the unit price. Okay, so guys, this column is represent for the 25%, and this is the 50% of order id, customer id, quantity, unit price, discount price. Okay, 25%, sorry, 50%. This is the 75% of order id, 75% of the customer id. So guys, this is calculating the 75% of each column. Okay, and here it is going to find out the maximum from the order id, customer id, quantity, and unit price. Okay, and this is used for find out the standard deviation from the order id, customer id, and this is the standard deviation for each columns. Okay guys, I hope you got it. This is the just summary of any data frame by using this df.info. Now we are going to use df.describe. Okay, so it is going to describe. I got warning. So it is giving us categorical column 2. Okay, so we have unique, count also 200, product and m 200, I mean product 200, category also 200, region also 200, and sales also 200. Okay, and unique, it is going to calculate 5. Okay, product, unique product, that is 5. Okay, and category also has unique, that its amount is 2. Okay, and region also 4, and that is also unique, and sales is 4, and that is also unique. Okay, and top, laptop, peripheral, south, allies. Okay, and frequency of them 50, 53, 110, and 56 and 54. Okay, so these are the regions. So guys, this is the frequency and tops and unique and count. So we can calculate for categorical data also. Okay, we have product, and product are also in a category. So that's why it is giving us for categorical data. Okay, now we are going to select the column in pandas. Okay, so how can we select? So you can see here, okay, column selection, 4 pattern you must know. Okay, so in pandas, selecting column is one of the most important, okay, most important and common operations. Okay, here are 4 important pattern you should know. So first is pattern 1, single column series. Okay, so selecting a single column, or you can say one column, it return the series, not a data frame. It is going to return the series and it is giving us single column. Okay, so here I'm going to print this. It is going to print single column. Okay, I'm going to remove this 1 minute and going to paste here. You can see here it is giving us type of this. Okay, pandas dot series, because I mentioned here type df revenue. Okay, so here we can select the single column. Okay, so this is like series. In pandas, in pandas we can select one column and it return the series, not a data frame. A series is like a single column of data. Okay, and then after this, okay, we will understand later that how can we print this. Okay, so after this we have second. Oh, you can see second one. Okay, you can see pattern 2, list of column data frame. Okay, so here select the multiple column. We are going to select the multiple columns here. Okay, to select the multiple column, pass a list of the column name. Here we need to pass column name, order id, product and revenue. Okay, and print the subset dot head. Okay, so it will give us 3 rows, okay, by using head. So here list of column, to select the multiple column, pass a list of column name and this return the data frame. Okay, I'm going to run this. Head 3 means show the first 3 row of the selected column. Okay, like this. Okay, it is going to show you 3 column here because I use head equals to 3. So we have order id, product and revenue. Okay, so this is going to select only 3 columns because I already mentioned here subset equals to, we have 3 order. Okay, sorry, 3 column, order id, product and revenue. Okay, and I use print subset, this is this variable, and I use head, that's why it is giving us 3. Okay, now we are going to check here. Okay, so here you can see here select by data type. Okay, pattern 3, select by the data type. Okay, so it help us filter the column based on their data type. Include equals to, here you can see I use include equals to number. Okay, select all the numeric column, integer or float. Okay, so it will select the number only, like it may be numeric or it may be float. Okay, so it will select the column based on the data type. Okay, so here I'm going to write, you can see numeric column, this is the variable df dot select data type. Df means we already have this df, this data set. Okay, I already mentioned this df. Okay, here, so df equals to, sorry, what do we have, numeric column equals to df dot select data type. This is the inbuilt method, and here I'm going to use include number, so it is giving us numbers, float or it may be integer. Okay, and column to list. Okay, it is giving us into the list. Okay, and print number of the column, and here I'm passed here numeric column. Okay, so here I'm going to run this. So you can see here this is giving us numeric column. Okay, you can see here this is the numeric column. Order id, customer id, quantity, unit price, discount, pct and revenue, these are the numeric column. You can see here customer id, order id, quantity, unit price, discount, pct, order id and revenue, these are the numeric column, guys. Okay, so this is giving us only column name. Okay, now we have fourth one, that is pattern 4, filter column by the name pattern. Okay, so sometime we want a column based on a naming pattern. Okay, so here we select all the column that contain id. Okay, so here I use loop. Okay, id underscore column, this is the variable name. Okay, and here c for c in the df dot columns. Okay, so in the data frame of, I mean column, I use data frames column here. Okay, and if it contain id, okay, then it will give us the column. Okay, so print id columns. So here I mention id of the columns. Okay, so you can see here id of the columns, order id and customer id, which has underscore id. Okay, now you got it. This is very simple. So with the help of this loop for c for, it will return the column. C means current column. Okay, c for c in a df dot column. Okay, if we have underscore id in a column, then it will return the column. So id column, it is giving us id column, order id and customer id. Okay, now we will see row selection. Okay, so I'm going to use ilog and log and dot ilog here. In pandas we use dot log and ilog to select the row and columns. Okay, so ilog means base label based selection. Okay, ilog means label based selection, use row and column. Okay, dot ilog means label based selection, or it is going to use row and column name. And ilog means position based selection. ilog means position based selection, use index position like 0 1 2 3. Okay, so this is one is position based selection and this one is used for label based selection. Okay, so I'm going to paste something here. Okay, I so you can see I already mentioned here, use the name index or boolean mask. So this is label base and this is the integer base, position base, or we can say integer base, used for the positional slicing. Okay, so here you can see select row by the index level. Okay, so here we are going to print df data frame. I already mentioned df here. Okay guys, so this is our df data and this is our product. Okay, so df is equals to our data frame and this is our data frame after print. Okay, df, so I'm going to select, okay, data frame df dot, I mention here there log or ilog log. Okay, log 0 product, so it is giving us at index 0 what we have. So we have tablet in a product. Okay, so we can search here. Where is it? I'm going to remove these two. So you can see it is giving us tablet. Okay, you can see here this is the 0 row. In data frame you can see here this is the 0 row and product at 0 row what we have tablet. Okay, so that's why it is going to print the tablet. Okay, and now what we have, select the multiple rows plus columns. Okay, so here I'm going to use df dot log. Okay, so it is giving us from 0 to 4. I means product start from 0 index, I mean 0 rows to the 4. Okay, so I'm going to print this one. I'm going to remove this one. So you can see here it is giving us product and at index, I mean at index 0 to 4. Okay, it is going to print 3 columns: product, revenue and region. Okay, we already mentioned name of the column, product, revenue and region, from 0 row to 4 row. So this is, you can see here I got from 0 to 4 by using this data frame data sets. Okay, so you can see here from 0 to 4 it is giving answer: product, tablet, monitor and phone. Okay, and region east, north, west. Okay, and revenue we have this. Okay, so it can print 3 columns till the 4 row, 0 to 4. Okay, so this is giving us row 0 to 4, product, revenue and region. Okay, after this what we have, ilog. I'm going to use ilog here. Okay, so ilog means positional base, work like a Python list slicing. Okay, so here I'm going to define sorry, I'm going to use df.ilog here. It is giving us slicing level from 0 to 3 and 2 to 5. First 3 row and then 2 to 5, 2 to 4 the column. Okay, so this is for first, it will give us first 3 row from 0 to 3, and it is giving us column 2 to from 2 to 5. So you can see here it is giving us column, sorry, first row from 0 to 3. These are the rows from 0 to 3, and column, so 2 to 5. Okay, G 2, 3 and 4, these are the columns. Okay, 2 to 5. Okay, so you can see here in data frame 2 to 5, 0 1 2, so 2, 3 and 5. Okay, so these are the columns 2, 0 1 2, these are the column. Okay, and you can see here, where is it, product revenue and region. I took 3 column from 2 to 5, product revenue and region, and these are the rows from 0 to, sorry, product category and quantity. So these are the product category and quantity, these are the columns, product category and quantity. So you can see 0 column, 1 column, column number 2, column number 3 and column number 4. Okay, so this is taking these column. Okay, and rows 0 1 2. Okay, so it is going to take 2 columns, sorry, 3 columns in between 2 to 5, and rows from 0 to 3. Okay, now you can see here we are going to filter. Okay, filter boolean masking. Okay, so this is also the core of analysis. Okay, so you can see here we have single condition. Okay, single condition. So I'm going to remove this one as of now. Okay, so we have single condition, this one. Okay, so here firstly in this we are going to filtering means selecting row based on the condition. We are going to filtering means selecting the row based on the condition. This is also called the boolean masking, filtering the selecting the rows based on the condition. Okay, so we have single condition, this one. Okay, so it is going to select the row where revenue is greater than the 500. Okay, it is going to select the row where revenue is greater than the 500. Okay, so high value, this is the variable name df. It is going to select the revenue where we have revenue that is greater than 500. Okay, and it is going to print. Okay, print in f string high value order. Okay, length of high value. Okay, so that is greater than 500. It is going to print revenue that has revenue greater than 5000, not 500, guys, sorry. Okay, so you can see here high value order equals to 31. Okay, so only row will true or cap. Okay, so this is giving us high value order 31, it is giving us row. Okay, so single row. Okay, so revenue greater than 500, it return true, otherwise false for each row. Okay, only row with the true or capped. Okay, so row number 31 has revenue greater than 5 I mean 5000. Okay, and you can see here after this one is used for length. This one length, so length give the number of the row after the filtering. Okay, length is give the number of row after the filtering. Okay, now we use, I think we have high value order that has, I mean 300 row we have. Okay, that has greater than 500, revenue is greater than 5000, not 500. Okay, so after this we can use multiple. Okay, so here you can see multiple condition. So select the order. Here we select the order. Okay, where region is north and product is laptop. Okay, you can see here we are going to select based on the condition north underscore laptop. Okay, so df inside this we are going to use data frame and region. Okay, so region equals to north, we are going to select the region, okay, that is north, and product is equals to laptop. Okay, so I'm going to use this. Okay, not this use for not, and we can use and. Okay, this one used for and this is for or. Okay guys, so here we are going to select order where region is north and product is laptop, and here it is going to print north laptop order length of north laptop underscore, sorry, north underscore laptop. Okay, so you can see here north laptop order, that is 17. Okay, okay, so it is giving us region, you can print like this also. Okay, so this for region and this for the product, that is laptop. Okay, so we have north laptop order 17. Okay, and high value order, that is 31. Okay, we have a high value order greater than 5000, that is 31. Okay, so after this after this we are going to use is in clear than multiple or condition. Okay, so here you can see is in, instead of writing multiple or conditional. Okay, so instead of writing multiple or conditions, instead of writing multiple or conditions, is in, I'm going to use is in check if the value exists in a list or not. Okay, it is going to check value exists inside the list or not. Okay, and select the row where product is either laptop or phone. Okay, so target underscore product, I'm going to take product. Okay, df inside this I'm going to pass column name, that is product. Okay, I use is in means check if the value exists in a list or not. Okay, here we are going to check if laptop is present in list or phone is present in list. Okay, then it will print the laptop plus phone order, uh, phone orders, I mean number of the orders. Okay, so targeted product, this one. Okay, so select the row where product is either laptop or phone. Okay, so we have laptop plus phone order, that is 85. It is giving the total length, I mean total number of laptop and phone. Okay, and after this we use query dot query SQLite, very readable for complex filter. Okay, so query allow us dot query allow us to filter using a SQL like syntax, more readable. Okay, so you can see here I'm going to use this line result equals to df dot query. Okay, inside this I'm going to pass revenue is greater than 300 and region in north and east, and discount PCT is greater than 0. Okay, so here revenue, this one, this is the revenue. Okay, and region is north or region is, we are going to find out the revenue where revenue is greater than 3000 and region. Okay, revenue is 3000 in region north and east, and discount is greater than 0. Okay guys, so you can see here region is north or east, this one, and discount is greater than the 0. Okay, so here we will get result and it will print the length of rows. Okay, filtering by the query, so filter by the query, I got 24 rows. Okay, where revenue is greater than 300 and region is north and east, and discount is greater than 0. Okay, this is simple filter. Now guys, you can see here adding, renaming and dropping column. Okay, so create a copy of the original data frame. I'm going to create a copy of original data frame. This is a good practice so we don't accidentally modify the original data. Okay, so this is the df2, I'm going to copy our original data in d2. Okay, so d2 equals to df dot copy. Okay, so I'm going to add the new column inside this D2. Okay, so create a new column, revenue per unit. This is our new column in D2. Okay, revenue per unit, and this formula calculate the total revenue, okay, divided by the quantity. Okay, so you can see here I'm going to use revenue. Okay, in D1 we have revenue. I also copy revenue inside this D2. Okay, so revenue is divided by the quantity. Okay, then it will give you total, I mean revenue per unit, and I use round equals to 2, so it keeps value up to 2 decimal place. Okay, and again you can see I'm going to adding the column with the condition np.where. Okay, np.where work like a if else condition vectorization fast. Okay, so logic, you can see here, if revenue is greater than 5000, np.where works like if else condition. Okay, np.where work like if else condition. Okay, so here revenue is greater than 500. Okay, and large. Okay, it means it is large. Okay, so np.where condition means if revenue is greater than 1000, it will be medium and small. Okay, so if our revenue is greater than 5000, it means it is large. Okay, if revenue is greater than equals to 1000, it is a medium and small. Okay, so if revenue is greater than 500, it is large. Else if revenue is greater than 1000, it is medium. Else it is small. Okay guys, else it is small. So that's why we use this. And remaining column, you can see here remaining column name for better readability. Okay, so rename the column. So df2, I'm going to rename the column unit price in price. Okay, we have unit price. I'm going to rename this unit price with price. And discount PCT, I'm going to rename discount PCT with discount. And in place true equals to modify the data frame directly. Okay, and dropping the column, so remove the unwanted column. Here we remove the category. Okay, so df dot drop, we are going to remove the columns. Okay, so column equals to category, I'm going to remove the column. Okay, in place equals to true. Okay, so it is also remove the column from D2. Okay, so here, so the selected column to verify the change. Okay, so I use revenue first, this one. Okay, and revenue per unit and deal size dot head. Let me check. Okay guys, so you can see here. Okay, so revenue, this one, I check revenue and revenue per unit and deal size. Deal size, what is this? Medium. This one is our deal size. Okay, so if revenue is greater than 500, so deal is large. Okay, you can see here revenue is greater than 500, deal is large. Revenue is greater than 300, deal is medium. Okay, and unit price equals to this one. These are the price guys. These one. Okay, so I hope you got it. And I'm changing this unit price into the price. Okay, revenue per unit. So I remove this category also. So I hope you got it. Now we are going to understand sorting in pandas. Okay, so you can see here first. Okay, so top 5 order by the revenue. So I'm going to use this variable top 5 equals to df. Df means data frame. Okay, and largest means it is giving you top 5 largest. Okay, so here I'm going to pass here top 5, that it will give you top 5 and revenue. Okay, so get the top 5 row based on the highest revenue. Okay, so here we are going to calculate top 5 rows based on the highest revenue. Okay, and revenue of order ID, product, region, and revenue. Okay, so get the top 5 row based on the highest revenue and large. So this is the value of n and revenue. Okay, so n equals to 5 here. Okay, so it return the top n or top 5 rows sorted by that column. Okay, and top order by the revenue, and print top 2 underscore string index equals to false. Okay, so you can see here it is giving us top 5 order revenue. Okay, this one by using this top 5 order by revenue I got here output. Okay, and we use order id, product id, region and revenue. Okay, so index equals to false, so that's why it is giving only order id, product and region and revenue. Okay, if you are doing here true, index equals to true, what happening here? So it is giving us like, it is giving like this. Okay, it is mentioned the index here. Okay, index, this is index guys. Okay, 57 31 11 2 16 2 and 160. Okay, otherwise if you put the false, then it is not giving us index. Okay, so now I'm going to sort by the multiple column. Okay, so df underscore sorted df dot sort columns. Okay, so sort underscore value, this means it is used to sort the data frame. Okay, so here we are sort region in ascending order. Okay, region in ascending order from A to Z. Okay, and revenue I'm going to sort in descending order from highest to first. Okay, so here region I'm going to print in a ascending order from A to Z, and we are going to use revenue in descending order from highest first. Okay, from highest first, so in revenue we got from, I mean, highest first. Okay, highest first, and region also in ascending order A to Z. And you can see here print df sorted, I'm going to use this variable, and here region, you can see here region, product and revenue I use head 8. Okay, so display the selected column first row. Okay, so it is going to selected column region, product and revenue. Okay, selected columns and first 8 row. Okay, and 2 underscore string index equals to false, this is not giving us the index. Okay, so I'm going to print this one. You can see here sorted by the region. Okay, and revenue in descending order. Okay, highest revenue first. Okay, you can see here revenue, highest revenue here. Okay, and product and sorry, and region also in ascending order from A to Z. Okay, so this is the region from E. After E we have actually I have only East. Okay, so it is giving region from the ascending order, that is A to Z, and revenue from highest to lower. Okay, and product same. Okay, so I hope you got it. Now you can see here method chaining. Okay, method chaining, write clean and readable pandas code. Okay, so bad approach, creating multiple intermediate variable make code messy and hard to read. Okay guys, so this is the bad approach, create a multiple variables. Okay, so creating a multiple intermediate variable make code messy and hard to read. Okay, so like temp1, in temp1 I put region and region equals to north, and temp2 I'm going to put temp1 here. Okay, and provide the product 1 and product revenue. Okay, so this is like bad approach, and in temp3 I'm going to use here temp2 dot group by product and revenue dot sum. Okay, so these are the bad method, I mean bad intermediate variable. So this is the bad, use intermediate variable everywhere. Okay, so how can we improve this? So we can use chaining, good method chaining. Okay, so method chaining means performing multiple operation in a single flow. Chaining means perform the multiple operation in a single flow. Okay, so I put here perform multiple perform multiple operation. in single flow. Okay, perform multiple operation in a single flow. Each step is applied one after another. Each step apply one after another, making code clean and readable. Okay, so here you can see result equals to df, and here I use dot query. Okay, so first step, filter the row where region is north. Okay, so dot query, I'm going to find out region equals to north. Okay, so first step, find out the region. Okay, so should I mention in comment here? So here I mention filter rows where region is north. Where region is north. Okay, and after this, group by the product. So here in second step, select only required column. Okay, so here we just select the required column. Okay, like product and revenue. And here in step 3 we are going to use group by. So group by the product here. Step 3, group by product. Okay, so group by here product with revenue. Okay, group by the product. And step 4, here what we have in step 4, calculate the total revenue for each product. Okay, calculate total revenue for each product. Okay, so that's why I use dot sum. And here step 5, sort value in a descending order. Sort in descending order. Okay, so here you can see sort underscore value. Ascending is false here, that it will give you value in a descending order. Okay, and here convert result back to the data frame. Okay, so dot index reset, I use this step 5, sorry. So convert result back to the data frame. Convert result back to the data frame. Back to data frame. Okay, so here it is going to convert result back to the data frame. And here we use rename. Okay, so here we are going to do what? Renaming. Okay, so convert result in data frame. After this, I'm giving here a space, guys. Okay, so here rename column for the clarity. Okay, so here we are going to rename the column. Okay, for clarity, and this one is used for the final display the result. Okay, so you can see here this is the better method. Before I use what? Like this. Okay, so in temp 1 I put a condition region equals to north, and in temp 2 I put product and revenue. Okay, and again I'm going to use here temp 2 and use the group by. So this is not appropriate way. Okay, so you can see here I use df.query and select the region and select the required column. Before I use like this required column. Okay, now I use column like this. Okay, and group by the product. Okay, so we can use group by like this, and we can calculate sum like this. Before I use to calculate sum, like this. Okay, and I use temp2 here. Okay, and again I'm going to sort column and sort value in a descending order, and reset the index and rename the column like this. Okay guys, so there is no need to uh, create intermediate variable like this. Okay guys, you can see I use group by. Group by means it is going to use group by here. I mean it is doing what? It is group all the rows. Okay, where we have product equals to laptop, mobile, whatever. Okay, so we are going to use group by here to group the product. Okay, so here you can see first we filter the data. Okay, first we filter the data, and second we select the required column, and then we use group by product. Okay, then we calculate the total revenue, and then we sort the result in descending order, and then we reset the result, and then we rename the column and save. Okay, so you got this one.